case, they want us to identify the precipitate or lack thereof. So precipitate means like a solid is formed in the solution. So that means, in other words, it is not soluble. So let's start off by writing out the first reaction. We have NaCl plus barium hydroxide and we need to figure out whether or not these products are soluble or not. So I'm just going to leave them blank. And we are going to look up the solubility rules and how to use this table. Okay, so here is an example of what a solubility chart might look like. So basically it just gives you all the rules and also with some exceptions to the rules. So if you have a compound containing lithium, sodium, potassium, or ammonia, these are always soluble. So you can see here the NaCl is aqueous. So that means I can also write that our sodium hydroxide is aqueous as well. Moving down here, so we look at what pertains to the barium chloride. So compounds containing chlorine, bromine, and iodine are insoluble only with silver, mercury, and lead, and they're soluble with any other ion. So therefore I can write that barium chloride is also aqueous. Okay, so let's look at the second reaction. So there's no precipitate in the first one. And now let's look at the second reaction. Like they already wrote aqueous there, but I'll just double check on our chart. Okay, so in the case of the silver, if we go back to that same rule where compounds containing iodine are soluble, except when they are paired with silver, mercury, or lead. So then we can say that this precipitates. And in the case of the magnesium, I believe since it is a 2A ion, let's try to find a table that has it. I believe this compound is just soluble. Yeah. Since it's an... I'll just put aqueous. Okay, so therefore... this is the precipitate. Okay, so let's see what the junior tutor said. Reaction 1, no precipitation. Reaction 2, it's the silver iodide. Explanation. When a substance is mixed with a solvent, there are several possible results. The determining factor for the result is the solubility of the substance, which is defined as the maximum possible concentration of the solute. Solubility rules help determine which substances are soluble and to what extent. It also helps in determining if there will be a precipitate in the products or none. Following are the most commonly used solubility rules that can help predict whether a compound is soluble in water or not. Okay, so they just summed up all the rules. Salts containing group 1 elements like lithium, sodium, potassium, cesium, iridium, all soluble, and salts containing the ammonium ion. With the nitrate ion and chlorides, okay, so they just said they are generally soluble. No exceptions. Salts containing chlorine, bromine, or iodine are generally soluble. Important exceptions to this rule are halide salts of silver, lead, and mercury. Most silver salts are insoluble. Okay. Most sulfate salts are soluble. And there are some exceptions as well. Most hydroxide salts are only slightly soluble. And the sulfides of all metals except barium, calcium, magnesium, sodium, potassium, and ammonium are insoluble in water. Carbonates are frequently insoluble. Chromates are frequently insoluble. Phosphates and fluorides are frequently insoluble. For the problem, number 1, rule number 3 confirms that barium chloride is soluble and will not precipitate as a solid, while rule number 1 states that sodium hydroxide will completely ionize, so there's no precipitate in reaction 1. For reaction 2, rule number 3 confirms that the silver iodide is insoluble and will precipitate in the solution. Rule number 2 states that all chlorides are soluble, which means that magnesium chlorate is soluble and will remain as an ionized particle. So in an item 2, there will be a precipitate in the form of silver iodide. Yep. So this solution is correct.